screen this guy. Alrighty, so I will just be given. Anyways, all right. So this is going to be kind of my lessons. Oh,
We're seeing
yep.
your presenter view, not the
Oh, I was gonna say that's what I thought was
inside.
happening. I was like, that's interesting. See, I don't even need the presenter view because I'm not planning on using that. But okay, let's just not do that. Let's see here. Let's see, how do I make it so you don't see presenter view? Okay. Well, I'll just do it like this. This is fine. All right. Okie doke. So this is going to be kind of just generally speaking, just lessons learned for me personally from the Suits Challenge. Olivia was actually kind of my mentor a little bit on the Suits Challenge. I joined when she was running the show, and very much learned a lot from her, and owe a lot to her. Ultimately, learned a lot from her experience there. Anyways, my name is Caleb Cram. I'm currently a XR Human Health Performance Engineer at Johnson Space Center. I got a degree in GIM from Boise State University, which is how I got involved with the Suits project. I was a Suits participant and eventually a team lead for a total of 4 years, from 2019 to 2022. But yeah, I've been a software engineer at NASA for around 2 years, roughly, as full time. But yeah, feel free to connect with me on LinkedIn. I'll also have that on a later slide. I'm always happy to answer questions later and all that fun stuff. But without further ado, let's just jump into the meat and potatoes. So, big thing. So, Suits Challenge experience. So I joined the BSU Suits team in fall of 2019. At the time, I was pretty new to augmented virtual reality software development. I was very much just looking for any interesting challenge to work on where I could learn more from it. And this was probably one of the coolest things I'd ever seen. There was a lot of intriguing stuff here to look at and learn from. And ultimately, my first year, I really didn't do much. I was pretty much just a fly on the wall. I tried to just learn as much as possible and kind of be a sponge. At the time, the team was working with Unity and the HoloLens 1. And so I was very much out of my depth software wise and was just trying to learn as much as possible and go to all the outreach events. Um, but then in 2020, I started becoming a little more useful. At that point, our team had some of our older members had graduated out, and so it kind of at that point I'd become kind of a middle member, and it was up to me to kind of pick up some more responsibilities. We're also in the process of updating from HoloLens 1 to HoloLens 2, which was quite the task. Earlier, Olivia mentioned refactoring. This was a lot of refactoring, a lot of rebuilding old systems and deciding whether we wanted to rebuild an old system or not, or whether we even needed it. And so that was where I really learned a lot about both the HoloLens 1 and 2. Really got deep into software engineering with that. And then in 2021, I took leadership of the BSU team. That was definitely a big learning experience for me. Olivia handled a lot of stuff, from communications to planning to just taking notes and things. And while she did a good job of handing off to me, it was ultimately a lot for me to try to keep up with. And so I think I was able to do an okay job, but I'm not sure if I really did quite as well as she normally did. But ultimately, that was a great learning experience for me where I really just dove in and kind of took leadership of the team. And then from that point in 2022, I tried to focus on handing over to our next team lead, just because I knew how long of a process that was. And I knew that I was about to be done with college and I would be a part of the team anymore. So I did what I could to try to hand over leadership and assist anywhere I could in that process. But like real big lessons I learned from this was to just observe. I mean, really, if you don't know what to do, then just sit back and listen and like ask questions. There's no such thing as a dumb question. I know it feels hard to ask weird questions like that, but it really is important to just go for it. Um, Also focus on like learning like as much as possible when you're doing that. It's easy to just sit back and kind of passively like listen in meetings, but like focus on like actually engaging with what's being discussed technically. And like if you don't understand what's being talked about, then like ask questions and try to keep up and learn. Because oftentimes these people are happy to share. Like anytime I asked a question, people are happy to teach me, and vice versa to others. And then a big thing is to contribute as soon as possible. I really didn't feel like a true part of the team until I contributed code to the code base. until I like really committed code and it was like actually used in the project, I didn't really feel like a part of the team. I mean, I helped and I like was around for meetings, but when you get to really contribute is when you start to feel like a part of the team and like feeling like you're actually doing something and learning from it. So it's good to get everyone involved as soon as possible in that regard. And then clear communication is hugely important. Olivia touched heavily on this with like Discord servers or Slacks or Trello or whatever your team might use, but it is important to like communicate frequently. Um, that is always a bottleneck that can slow things down pretty bad. And then take leadership. I mean, as vague as that sounds, even as small as like just taking leadership over a certain functionality within the team. Like say something needs to be built and you think you might have an idea for how to do it, go for it, try it. I mean, even if it doesn't work, just throw paint at the wall and see what happens. Give an attempt, and next thing you know, you'll end up running the team. Fast forwarding a little bit to internship experience. So Suits is very much what got me kind of a foot in the door with internships. And that was via experience from what I learned at Suits. Not really like anyone that actually helped me get in, but just the things I learned ended up making me exactly what was needed for some internships. And so my first was up at the GVIS lab, the Graphics and Visualization lab up at Glenn Research Center. I had maxed out my internship applications getting to that internship. I think I'd done as many as they would take. And I think I did that for every internship cycle. And so, note there is to be persistent, cast a really wide net. You know what I mean? Like, you will be told no more than you'll be told yes. And so just, apply as much as you can. Um, but ultimately, what got me that internship was my portfolio. I had a website that showed what I'd been experimenting on. And after going through it in the interview with my internship mentor, he asked, he's like, what were these projects for? Like, who paid you to do it? What was it for? And I was like, oh, I just did it to learn. Like, I just want to know how this would work. So I did it. And that's a good thing to do that is worth a lot. And like, that is invaluable in an interview and people appreciate that. And that is kind of what got me that first internship. And then my work there got me 2 more internships there. And then I ended up interning down here at Johnson Space Center on the IoT holographics project. And I was specifically selected for that just because I had a lot of experience with the HoloLens 2. Again, experience from Suits was hugely valuable there. That was where I really kind of cut my chops on development for the HoloLens 2. So that came up a lot in the interview and was a big part of why I got that internship. And I did that for a second semester for my 5th internship, and then went on to full time after that. But the big things I learned from all that is that it's really important to like be persistent and like keep applying and keep trying and like don't give up. Like I almost gave up on working at NASA like a few times. Like I was like, oh man, like I'm not gonna make it in. I'm just gonna take whatever internship or job I can get. Um, and like just keep applying, right? Like it's one of those things where it's like if you look for the right spot, you'll find the right fit. Also self-teach is huge. Like you got to be able to teach yourself. You got to be able to experiment and like then showcase what you've learned, right? Like it doesn't help to know a lot if you don't know how to show what you know, especially in an interview. And so be able to like narrate what you've learned and how you learned it. And then moving on to NASA experience. So I was at the end of that 5th internship, I was searching for a job. I wanted a full-time job. I was not trying to be an intern anymore. And the Apache team, which is where I work right now at Johnson Space Center, was in search of an XR software dev. I was not aware of that, but a connection I made through Suits, unbeknownst to me, recommended me to the Apache team, and a recruiter reached out to me via LinkedIn. And next thing you know, I had an interview and I had an offer within the week. Fast forward 2 years, we're here to today. I've gotten the opportunity to work with a lot of really unique hardware, such as like an Infinitec omnidirectional treadmill, 6-off motion platforms, lots of interesting biomedical sensors and research. And so, yeah, it's just been a really interesting ride. I learned a lot from it. And ultimately, Suits was what really kind of kickstarted my learning that got me here. It's what kind of gave me the initial ground set skills I needed to do all of this. Um, but yeah, and one big note that I've learned from my time at NASA is be ready to seize unique opportunities. Things will pop up randomly out of nowhere all the time. And if you're willing to just jump up and say yes and do it, even if you might not know how, just be willing to try. You will thrive. But yeah. So on to specific tips and tricks. So for technical advice that I have, things that I'd really recommend focusing on, get hands-on with the hardware as early as possible. Just try it, experiment with it. Even if you're just playing games on it, just get hands-on with whatever hardware you plan to use, figure out the bugs, the quirks, the tips and tricks, things that are good, bad, and ugly, and then develop with all of that in mind. Because the sales pitch doesn't always match the functionality, and you need to make sure you know the limitations of the hardware as well as the capabilities. And also experiment and explore. I know it sounds really vague, but like really just try stuff. Like even if it doesn't have an obvious use case for the challenge, just try it. See, like this is all to learn, and so that's what you really need to do is just experiment and learn. Also, as I said earlier, refactoring and dependencies are hard. When you have lots of toolkits that are all interdependent with each other, or maybe don't play nice with each other and are updating at different paces, it's really hard to keep things functional and working. And so you need to be careful with what you do and don't update. Also, don't always build everything yourself. Sometimes it's nice to build a system yourself. Other times, maybe not. If there's something that provides a good hand tracking algorithm and things like that, then maybe you don't want to train your own from scratch. Depends on the use case, and so do that selectively. Also, be sure to work collaboratively as a team, ideally in person. From my experience, it's not that you can't work remotely, but in person you tend to catch things that slip through the cracks when everyone's remote. It's easy to overlook things when everyone's just on a call as opposed to being there in person. Also, write your code to be scalable. I've done this to myself so many times. I've written things that work for the moment. It was a quick Band-Aid fix, and then 6 months later, I'm trying to remember how it works so I can make it scalable and not awful for what we need. And it's better to just make it scalable from the start, or at least document it well so you know how to improve it. Also, build small and iteratively. Olivia went deep on this, but really just build a little tiny bit at a time. You don't want to, build the entire car and then realize you don't know how the wheel's going to work or how the engine's going to work, right? And then, as I said earlier, update with caution, right? Like if an update's worth it, go for it, but like do that carefully because that can backfire pretty aggressively. Next would be like managerial type advice. So this is a big thing, kind of like I was touching on earlier. Contribute early. Get everyone in the team to contribute however they can in the most substantial way they can as early as they can. Because until you feel like you're contributing, you're not really going to feel like a big part of the team, right? And like not that you're not a part of the team, but that's just how you tend to feel. And so it's good to get people in and like get them contributing in whatever way they can. Also, code review as a team. This is something that we did not do as good of a job on as I would have liked, but really just sit down and go through the code as a group and like check everything and like, just bounce ideas off of each other. Also use version control and regularly check in. Don't, this is something that you will have to do for work anyways. So you might as well learn to do it now and get good at it now because it'll help you in interviews and you're going to have to do it if you end up doing any full-time software development. So it's definitely important to learn that. Also document code and not just with comments in the code. I mean, write documents that explain what your code is doing, how it works, how it functions with the application. This is something that I did not do very well at the time in the challenge, and I regret it because it made it really hard to pass off to new team members. You really need to document everything very well. Just because you put comments in the code doesn't mean that new team members are going to know where to even look to find those comments. Also, every feature or task that you're trying to develop needs an owner. You got to have someone that's in charge of doing the thing that you can go check with. That way, the team leader can go check in with the sub team or the person that is in charge of that thing to make sure it's happening, or find out why it's not happening and decide if we either need to like brainstorm as a group to figure it out, or maybe divert and try something else. Kind of like Olivia applied in her earlier, right? Like maybe what you're trying to do is not the smartest thing, and maybe you can rework it or work around it in a different way. And that's important to help keep track of that. Kind of like I implied earlier, things can be missed with remote work, so just keep track of things. If you are working remotely, like be really diligent with that and like try to keep in touch together, like test things in person whenever you can, and prioritize tasks. This is so hard to do, but so important. Everything's a priority. I know, I understand. It's still like that even with full time. Everything's always a priority, but you have to pick your priorities and get those done first and make sure that you have something that is actually testable when you show up to do testing with people, right? Now something that's a little more up my alley, doing human performance research, is going to be user research advice. So specifically, have a clear, concise EVA circuit or set of tasks that are planned to test with. Olivia touched on this, but like have a set plan of when we have a test subject, we're going to test A, B, and C, and we're going to do it in this way, and here's the results we're looking for or the data that we're going to collect. Because if you don't have a plan, then you're going to get a lot of hms and ha's and ooh, ah, shiny, and nothing really actionable. Also, use a wide variety of test subjects. This is something that we need to do. We do it here in the lab. You have to do it all the time. Just get as wide a variety as possible because there's things you will miss if you don't test a wide variety of people. Like Olivia was implying earlier, if you only test college-age students, there might be more familiarity with technology than if you test a wider age group. And there's lots of things like that that are easy to miss. Also focus on intuitive design with minimal instruction needed. You don't want to have to like massively instruct your person like how to get through something. You wanted them to be able to just jump in and understand what they should do. It should be relatively intuitive ideally. And if it's not intuitive, that's why you do user testing to figure out where it's unintuitive and then how you can change that. That's where the subjective feedback is going to be really helpful. Also use physical mockups wherever relevant. For example, if you've got a task board you can interact with to switch switches and flip things and turn dials and interact with stuff, do that. It's good to have. Not necessary, but it's nice. Also study your test environment limitations. This is something that I struggled with for sure, where you might have network limitations. Like say you're relying on a lot of Wi-Fi bandwidth and that maybe that's not available where we're going to test. Or maybe you're not ready to deal with low lighting environments or like really bright floodlights at night, and like that's something that you might have to deal with. And so these are all things that you need to look at ahead of time and plan for. Also record and document everything you can, like testing, all of that, just for future team members to have for reference. Keep it organized in some way, whether you have like a team drive or something to keep track of all this stuff. Keep all of it and keep it as organized as possible because future team members will need this to kind of like look back at what was done and figure out how to improve upon the project. Also, capture feedback from subjects. This is incredibly important, not just to get it once, but try to get it before, during, and after the test, if possible. Now, that's dependent on what your testing is and how you're testing and what feedback you're getting. But you want to be getting feedback like before they get into something to know like, okay, like have you ever even done VR before, right? Is this your first time in any augmented virtual reality headset? And if so, like we need to know that just to know, right? You want to have the data for that for future reference. Anyways, yeah, so it's good to do kind of before, during, and after your testing. Also use standardized measures wherever relevant. So for example, in our lab, we use NASA Task Load Index, the Bedford Workload Scale, the Cognition Test Battery, and the Simulator Sickness Questionnaire on basically every single study that we perform. We do a lot of human subject research, and almost all of them use these in some way or another. So if there is a point where you have an EVA task circuit or something developed where these are relevant, then use them. They're good measures to have. They're currently used in a lot of published research, and it kind of helps add concrete numbers to back up your subjective data when you're getting feedback from subjects. Going deeper into what those are, here's the NASA Task Load Index itself. So this is mostly meant to assess like workload demand. It's mostly useful for looking into like hardware familiarization or like task familiarization, trying to figure out like how difficult it was to learn how to use something or get adjusted to something. It's good for figuring out like a task complexity. So if you have like a really complex EVA task that's like really cognitively demanding or really physically demanding inversely, it's really good for looking into that and diving into like how exactly that works and like why. It's also good for, as I kind of implied a second ago, looking at cognitive versus physical demand and like seeing where that demand is coming from. And the way it works is it's probably kind of hard to see. I try to get the picture big, but essentially we're looking at a scale from 0 to 100. We're getting a feedback from the subject of, okay, what was your demand for, say, mental demand on that geology task we just made you do? Would you say it was 0 being low demand and 100 being high demand? Where would you rate it? And say if it was really hard for them to decide like which rock to sample because we made something really complicated, then they might respond, oh, it was like it was a 60. It was really, really high demand. It was pretty difficult. And we'll go on down the line. There's like mental demand, physical demand, like temporal demand, which is like how much time pressure they felt. We'll ask them like how they thought they performed, what level of effort it took to get that performance, and like what kind of frustration they felt throughout that process. But yeah, there's lots of documentation on this online, and this is something that is good to get kind of concrete numbers to back up your subjective data, because subjective data is good for actionable improvements, but it's hard for getting kind of broad summarizations of data over lots of users. Another important one is Bedford Workload Scale. This one's pretty quick and easy. It was developed for usage with pilots, but it's basically a little flow chart. You'll just start off with, was it possible to do the task? Yes or no? And you'll just go on down the line. Was workload tolerable? Yes or no? Okay, was workload satisfactory? Yes or no? And then that'll take them to a certain point inside the flow chart where they'll either be, okay, workload was insignificant, workload was low, or it could go all the way up to, workload was extremely high. They had no spare capacity. They have serious doubts on the ability to maintain this level of effort. And this kind of lets you gauge the difficulty of a task, whether it be cognitive complexity or, kind of like just like how hard something is for someone to handle over a long period of time. Like if you're asking them to manage 3 or 4 different times at once, 3 or 4 different tasks at a time, this can help you gauge if they're losing track of that or if they're struggling with it. It also helps you gauge like the likelihood of actually completing a task. In your guys' scenario, I assume your EVA scenarios probably won't be anything so hard that someone couldn't complete it. But if that is the case, this will catch that. It also helps catch familiarization over time. If you have someone do this, do this test repeatedly over a series of weeks, say you have a test subject you bring back to try your software repeatedly over the course of a few weeks, you could give them this each time and see how they improve over time and kind of see what their learning curve is with your software, as they say that their subjective workload was lower, essentially, or maybe higher if your software gets more complicated. It depends on what you do with it. Another really important one is the simulator sickness questionnaire. This is great to do before you put people in VR. It just kind of gets a prequel, like, okay, what is your baseline symptoms of all these things? And then put them into VR and then have them go and do whatever they're going to do. And then you can kind of get this afterwards. Or if anyone does feel motion sickness or anything uncomfortable or anything that they don't like, then this can be a way to kind of gauge those symptoms and help you kind of identify like, okay, is it like frame rate in our application that's causing discomfort, or is it maybe something else? Yeah, this is great for just checking your app performance and like making sure that like everything's good to go there. You're not going to cause motion sickness. Also, it's good for screening prior to testing and monitoring during testing. So we do this during a lot of our studies where whenever we're having someone do something really complicated in VR, if there's a point where it looks like they're struggling at all, we'll just kind of ask them like, hey, like we're just going to run through this simulator sickness questionnaire. Just let us know how you feel verbally, and we're just going to ask you all these categories, right? And these are good things to run through for that. This also helps to build data to define like what you should be optimizing within your software. So if there's a certain thing where, say, every time we enable this certain menu or this certain functionality, people report like eye strain. Okay, maybe we should look at the intensity of the color or the brightness of the headset or something. Like maybe there's something causing that in the software, not just people being uncomfortable. But yeah, it's good to get data to back this stuff up. And then you want to analyze that data so you can determine like where you can actually improve, like what you would want to make better. Arguably your most important data though is going to be open subjective feedback. This is going to be very valuable. This is typically where you get most of your actionable improvements from. This is where people tell you, hey, I don't like A, B, and C, or I really wish we had 1, 2, or 3. And then you can go add that to your to-do list to go improve, depending on what it might be. Other measures will give you like rough numbers and estimates, like, and they're great for getting kind of numbers over vast pools of subjects, but for getting immediate feedback on how to improve your application, subjective feedback is always going to be your kind of gold standard there. Because it gives you like true experiential feedback from the subject. The challenge is it's unpredictable. You don't know what they're going to say. You can't give it a rating on a number scale. It's just a lot of words usually, right? Which you should probably make sure you're recording or writing down in some way. It's difficult to document concisely. It's really hard to like concisely, neatly package subjective feedback. It's also difficult to share with future team members. Usually there's a lot of context between like, okay, in this specific test, and like someone will be like, oh, earlier when I did this thing, I felt this way. And if you weren't there at the test, then you don't know what that was, right? And so it's something that's very hard to pass on to other members. It's very experiential. Also, it's difficult to act on if you don't do it quickly. It's easy to forget what that conversation was, and that's why it's important to record it and write down actionable points very quickly. Also, Olivia touched on this, but brutal honesty is really hard to find. We run into this with test subjects in our lab frequently, where it's hard to find people that are brutally honest with you, and it's a blessing when you do, because they'll give it to you straight and help you really improve what you're doing. Um, Also, you have to get past the wow factor of the tech. Some people that have never tried VR or AR just are blown away that it's a thing and that it exists, and that's cool. But that's not what we're here for. We're here to do research and to develop software. And ultimately, like, the wow factor doesn't help you a whole lot. It's really cool. It's fun. I love it, but it's not going to help you with your actual research. So here's some quick resources I referenced. I can send links to this later if you'd like. It was just kind of resources talking about the different scales and workload things that I talked about, as well as some work my lab does. But with that, I don't want to keep you guys too long. Thanks for listening to me ramble. Feel free to connect with me on LinkedIn. That's my little handle there. And any questions?
Yeah, thank you so much, Caleb. So yeah, any questions, feel free to ask those. I did see Olivia was able to join us, so she was able to get away from her work commitment. So if you have questions for either of them, please feel free to either um, type in the chat or come off mute and ask it. So any questions for Olivia or Thomas or Olivia or Caleb and their experience with NASA suits?
I've got a quick question if you guys don't mind.
Yeah,
Um,
absolutely.
so I guess one of the biggest things that I try to be mindful of is I'm vaguely familiar with the concept for Agile of story slicing. Now, with that understanding it as it being a concept, I'm not quite sure how to really conceptualize how exactly do you understand, yes, this is going to take this amount of effort per se.
Yeah, no, that's a really good point. I mean, part of it, and this is, I mean, I'm going to give you an answer by giving you a non-answer, and that is that part of it is that you don't know how long things are going to take until you try. I mean, you can guess all you want, but that's why it's so important to experiment early and quickly, because, I mean, your best bet is to guess however long you think it's going to take and then add at least 20% to that so you have buffer. Because odds are some things will be easier than you expect and you'll get time back. And then some things are going to be exponentially more difficult than you expected and you're going to lose time from those. And hopefully you built enough buffer into your schedule to end up kind of even out at the end. But that is a hard one.
Yeah, I 100% agree with that. The buffer is important because you're never, I mean, even like super experienced software engineers they can't predict it with 100% accuracy. One strategy that can sometimes work is thinking about it like in magnitudes instead of exact predictions. Like, you think it's going to take days or weeks or months. And even that can sometimes be wrong. You never know when the big gotchas are going to come up, but people are at least a little bit better at guessing magnitudes usually.
Well, thank you. I figured that's kind of the nature of Agile's iterative part of it, you know. Thank you both.
All right. Question in the chat. If you had to start the suits challenge from scratch with absolutely no prior work or experience to go off of in regards to the challenge, how would you get started? Big question.
That is a big question. I can start, and I'm sure Caleb has a good perspective on this too. Well, I did that like however many in 2018, however many years ago it's been. We started a new team at Boise State, and none of us knew how to program for augmented reality or anything. Honestly, my best advice is probably just to get your hands on the technology and try things as soon as you can. You can spend as much time as you want doing research, but ultimately you're going to learn the most from doing the thing, seeing what works, getting a build on the HoloLens, and kind of letting your plan come together as you build that working knowledge. But yeah, I'd start developing, find a tutorial as soon as you can.
Yeah, I can't agree enough with that. yeah, that was very much where the Suits project was useful for me because it allowed me to get hands-on with these hardware like HoloLens 1, HoloLens 2, and like work with other people that were more experienced than I was and kind of learn from them. And it's one of those things where it is invaluable to just dive in and break things until you learn how they work. I mean, really, it's how it goes. I mean, you can read documentation all day, but most of the time the documentation isn't even up to date anyways. And so you're kind of just better off digging in and seeing how things work. And you'll learn a lot that way.
Great advice. And I know one thing I was talking to Geraldo earlier today, we were talking about kind of what to do in this couple weeks and working on the AI components and just familiarizing yourself with kind of how you can use AI for particularly that predictive modeling of either route finding or resource use. So play in that space. Any other questions? Which we'll have questions for suit specific here in a moment or challenge specific. Anything else for Geraldo or Olivia? All right. Well, I'll move on to announcements, and then if another question pops in the chat in the next couple of minutes, maybe Olivia and Caleb will still be here. So did want to jump into kind of our suits housekeeping, if you will, with just some, I'll use the word announcements for that. So first is just a reminder, one of our kind of early deliverables is a introduction video for your team. So that's kind of coming up next week on the 23rd. The production value can be whatever you need it to be or want it to be. So you don't have to crazy stress over it. And if you go to Canvas, those of you who are in the Canvas course for suits, it's there's an assignment, it kind of goes through the requirements, expectations, hopes, and then that's also where you can submit your video. Our preferred method for submission would be you upload it to YouTube, either public or unlisted, your choice. And then you can that link. You can also upload like an MP4 file or whatever. So there are other methods. YouTube's probably the easiest. And then one thing we try to do is then like create a playlist of each team's videos and share it with you all, so you can meet each other. Number two is mentors. I know I shared this with team leads on Tuesday. So be trying to set up that first meeting with your team's mentor from NASA. Try to get that meeting planned soon, and then executed by the end of the month, and then establish a cadence with them. Also, our next mission briefing will be at 4 p.m. Central on February the 6th, so about 3 weeks away. That topic will be the tech team deep dive, so it will be kind of our technical leads here at NASA sharing more on the challenge. And on that, the telemetry stream and kind of the dust, we're hoping to have a version to you all by the end of this month. Actually, we're trying to have it by the end of next week, but for sure by the end of this month, so the next 2 weeks. So when that is shared, definitely like open it up, poke around, try to understand it, see what questions you have, because like if we get it to you on the 31st, that will give you then until the 6th to come up with great questions, because part of that tech team deep dive with Geraldo and the folks who developed that would be, hey, we were looking at this and we don't understand how this works. And obviously you won't know what you don't understand if you haven't dug in yet. So we're trying to get that to you as soon as possible. And then that next mission briefing is there on the 6th. GitHub. So I've reached out to team leads, and most of y'all, about half of y'all, have provided usernames to add to each team's repo in GitHub. So if you haven't yet, send those to me when you get a chance, and we'll get them added. Again, we got a couple weeks, so we'd love to get that all in. And STEM Gateway. So I know I've shared this with team leads, but we would need every team member be added as a participant in the STEM Gateway. So that process starts with team leads. They add your name and email address, and then it goes to a status of invitation sent. So right now, when I looked, we have 55 people that are kind of in that status. So like you've been added, but you need to either receive that email and hit accept or log into your gateway account and hit accept. and then we'll move from invitation sent to submitted status. And then we go manually and extend an offer to participate in suits, and then you need to accept that offer. So as we're at right now, that being said, these numbers were current as of Tuesday. So we had 55 in invitations sent, 43 with a pending offer. And then 152 of you are all the way through to accepted offer. That being said, a pending offer, they expire about once a week. And so I just have to go click re-extend offer. Great question, Dr. Johnson. You do not have to be added if you do not want into STEM Gateway, but you are more than welcome to. The biggest thing is it helps us just keep track of who is participating, and then we can kind of also look at like demographics of who we're reaching. So feel free to have your team add you or not. I think they would be adding you in the role of just like a student. They did already write your name down as the faculty member. So either way is fine with us. Some teams I know do have their faculty also as like a team member as a student. So whichever way works for you. And lastly, so each Tuesday-ish, sometimes it might slip, we do send a weekly email. So hopefully you're all receiving that. We did send one on Tuesday, this Tuesday and last Tuesday. So if you're not getting that, reach out to us and make sure we'll get you added to that mailing list. It will include things like the link to join this call and just other news. And if anything's ever unclear in any of our communications, ask. Sorry, there's a weird noise happening. So let us know. And that is it for housekeeping from me. So again, any questions, let us know. Last I looked, Geraldo is on the call. So if you have any specific technical questions right now, he might have dropped. He was on the call. Now I'm not seeing him currently in. But yeah, any questions you have, let us know. Or if any other questions came up for.
I have a general question. Can you hear me?
Yep, I hear you, Josh.
Okay. Do you guys have any tips for delegating tasks or even whole sub-teams? How to avoid, you don't want to directly choose people over others and then have there be conflict within the team. So how do you go about that?
I'm going to let Olivia or Caleb take that because I have not led a suits team.
I'm trying to understand your question. Are you talking about like the process of choosing leaders for sub teams specifically?
Yeah, I guess that's the biggest challenge that I'm thinking of.
Yeah, let's see, what would I say about that? I think, Caleb, were there sub teams on the suits team with Boise State when you were involved?
Yeah, so like kind of, but effectively there was like four of us that just did a lot.
Yeah.
So it's one of those things where it's like ultimately our team was never big enough to have like infighting between like, oh, I want to be team lead, I want to be team lead. It's mostly like pulling people's legs to get them to lead. Because most of them just wanted to do the development or like wanted to do the design or like they want to do that one thing, which is super awesome. And like you want to have them doing that one thing. So like ideally you want people doing like what they want to do and like what they're good at. But also like yeah, we didn't really have a lot of like infighting over who wanted to be leading things necessarily.
Yeah, that was kind of my experience too. I would say like if you're having problems with that and people are like really wanting different roles, you could consider doing it democratically, like have the team vote. Then it's not on any one person's shoulder who gets that role. The other thing I'd say like is if there's a ton of people who are super like passionate about leadership, like are there more leadership roles that you could add? We on Boise State had an outreach leader. That was a really great role, like social media leader. There's all sorts of things that maybe is you would just automatically think that as a team leader, whoever you would do, but like if you have one person focused on those things, they can expand into something even bigger and greater. And if people are passionate, then you can definitely think about adding more positions.
Yeah, I know having a dedicated outreach lead was always a huge help because that's a lot of communication with a lot of people, and it's a lot for the team lead to keep up with while also leading the team. So it's great to have someone to manage that.
Yeah, testing is another thing. It's great to have a UX testing lead if you can.
Josh, if it helps at all, I mean, with our team, we're kind of figuring out like sub team leads. So like Adrian's our team lead for as a whole. But like within our teams, we're figuring out sub team leads. So, you know, we have people that are over human in loop testing. We have people over particular developments and, you know, working with project management, working with the outreach. And so we have different pieces that we're at, but we also had that, you know, as Caleb was talking about earlier, we had a little bit of like that brutal honesty about like, hey, if everyone's a team lead, then nobody's a team lead. But I guess there's also kind of that element of like, you know, taking the ownership over certain things. Is it that you want to be a leader, or is it that you want to own that piece? So it's, I guess, part of that conversation is, you know, what is it that you want out of the leadership, and what are you looking for from it?
Yeah,
Yeah,
that's a great way of thinking about it. And if you if you can break your software into or your plan into big meaty technical areas that you need somebody to lead, that can be great as well. Sorry, Caleb, I think I interrupted you.
Oh no, you're right on the money of what I was saying. I mean, if you have a big enough team to be like kind of worrying about that, or like if people are worried about that, it's great to be able to have enough people to actually just have people dedicated, like, hey, are you, so if someone's interested in the software development or the technical part of it, let them just go all in on that. And like, you don't want them leading the team. You want them to just be a developer that's all in on whatever they're working on. Or if you have someone doing UX development or design, you want them to be all in on that as much as they want to be, right? Obviously, you want to give people the opportunity to try different things because it's an opportunity to learn. But if you've got enough people to let people really dial in on that, then it's good to have those people do their specialty and then have the team leads really just focus on kind of organizing things and running their sub teams.
We have a great model for that actually at Microsoft. Now that I work here, it's been kind of cool to see. Because I think in the past and in some other companies, it's like to get to a leadership position, you have to become a manager and you have to manage people. But at Microsoft, we have a concept of principal ICs or individual contributors who are they're super high ranking, but they just develop and or they just for PMs, they just write specs. Because that's what they're good at and that's what they like doing and they're super valuable. And that's why we have the system now to promote them highly, but they don't want to manage people and we don't want them managing people because we need all their brain power for what they do. So you can think about that kind of paradigm in your team as well.
No, yeah, that's smart. I know we've done similar stuff on like the contract side at NASA where it's very much like we've got subject matter expert people where we don't want them to be in meetings. We don't want them to be answering emails because they're busy doing something technical and that's what they're paid to do.
Great answers. And I think
Yeah,
also
thanks
just
everyone.
because you're not if you're the team lead of one area, you're still contributing to the others. Like, you still go to those outreach events or the testing, like do all the things if needed. But perfect. All right. Any other questions? Awesome. Well, thank you all for being here. I'm gonna stop the recording and then we'll wrap up. So thanks again, and we'll see you here in a few weeks.
Thank you both for coming by.